Okay. మీటింగ్ ఉంది, నువ్వు తలిపేసేసి వెళ్ళిపో. Shall we start?
Yes, sir. You present your screen.
Sure.
Yes, sir. We can start now.
Yeah, it's something happened. I'm just trying to retrieve my PPT. Yeah. You start?
Yes, sir.
Just a minute. I'm just trying to check whether we are. Okay. Hi. Good afternoon, everyone. This is Dr. Venu Gopal Jarugumalli. I'm actually a data science evangelist, and then had more than 15 plus years of experience in building models. And like, no, I'm actually a subject matter expert on manufacturing and trying to evangelize AI and ML. Okay, that's me. So today I'll be talking to the data science community of SRM group. So before starting my presentation, I'll be discussing today like how to deploy an ML models in a production environment. Okay. So before that, I just want to start explaining about like the linkages between machine learning and artificial intelligence and data science. Okay. So data science is a discipline where data is used and analyzed to hypothesize, answer questions, and understand insights. Okay. And whereas machine learning is a computational tools and statistical techniques that are leveraged to give computers the ability to learn from and with the data. Okay. When it comes to artificial intelligence, is when a computational tool starts to processing cognitive abilities to help in decision making process. So what I mean to say here is data science is a more like a discipline, and machine learning is basically an tools and techniques which we use in discipline, and artificial intelligence is basically a decision making process. So what happens when we try to understand what is data science, data science as a services, right? So I am a strong believer of something like data science as a team sport rather than like data science is an individual person will do all the things and all, right? I say it's a team sports because it has statistical learning, machine learning, programming, and people require maths, people require signal processing. People also need to know about performance and high performance computing. There is a branch called linguistics, operation research, storage, and data structures. All these elements comes here, right? So there are different roles and different components in a data science, right? You can actually start something like data visualization. Okay. So you can also have in big data. You can also need to have a business acumen, and then like if you see this entire framework, I'm trying to say a data scientist who covers a broad spectrum of things. Like no, he can be a programmer, he can become a business analyst and statistician. Okay, and then he can become this, and then you can actually see this at different stages. Like no, a personal way to analyze this is first to have a data quality, descriptive, diagnostic, predictive, and semantic, and all these different stages has to be done with a data scientist. Okay, so with this we'll just try to understand how the data science life cycle emerge in any project, right? So there is a famous methodology called CRISP-DM, okay, where people are following for measures. But what is happening is in recent period, with the upcoming things like Agile and upcoming things like no, all the data project lifecycle premises. So the data lifecycle has come into place. So the starting of data lifecycle, people should have a business understanding, then people should acquire the data and understand it from the sources, build pipelines and the environments and wrangling of it. Okay. Once they acquire the data, then the whole gamut of thing modeling will start. Modeling starts with feature engineering, model training, and model evaluation. So once the modeling is done, that's where the deployment will come, right? Where to deploy this model, right? So where to store the model, or whether we need to go with a web service, or whether we need to go with a mobile application, or whether we need to do an build any intelligent application. Okay, this all deals with deployment. Once the deployment is there, then the customer accepts this, then it becomes the end of the life cycle. So that's how this entire data science life cycle works. So in this data science life cycle, what we are trying to focus today is on deployment, but we'll need to understand the different stages of the data science life cycle to get into deployment. Okay, so I want to start with enterprise data science. As we talked about, it's a team sport, and who are the people involved in it, right? We need to have a data engineers whose role is to do ingestion and preparing the data, and we also need to have business analyst and data scientist who will basically explore and analyze the data. Okay, and then we also need a data scientist where we'll experiment and train the data. Then comes the DevOps and developers will optimize and deploy the model. So this entire managing and governance has to be dealt with data scientists and DevOps guys. Okay. Now we are calling them as MLOps. I will discuss that also. What is the difference between DevOps and MLOps? So the whole concept here is train the model, package the model, validate the model, deploy the model, and monitor the model. These are the 5 important steps in entire process of this. Okay. So as I said, it is basically an inherently a team sport. It is not a one man's job, or it's not a software job. Okay. Now we were talking about how the data science skill sets works and data science team should consist of. We should have a data translator, we should have a data engineer, and we should also have a data scientist. Okay, a data translator should be a pretty good guy who can visualize and who can have a good business understanding. Okay, then a data engineer is a guy who can go and wrangle the data, and then who also needs and possess the skills of a software engineer. Okay, who can do this bit of automations and other stuff. And then here comes the data scientist who should be fundamentally strong in mathematics and statistics, and at the same time should be very good with the machine learning uh, algorithms and stuff. Okay, this is basically a skill set required for them. Now, when we go into this entire concept of this entire thing, no, as we talked about data warehouse, that's where we acquire the data, then we prepare the data, train and test the data, we'll develop a model, and then we test a model, and then that model basically goes to results evaluation, then we deploy it. So that's the deployment where we'll talk about MLOps. Okay, so I'm trying to put this concept of ML ops because it's not the DevOps. Okay, DevOps is a different thing where ML is basically a very important concept which you are trying to put. So the components of ML in a developing and an operating environment is called ML ops. Okay, so first is basically data acquisition, business understanding, initial modeling is ML, then developing a model plus testing and continuous integration, CI/CD process is basically in DevOps thing, and then operationally continuous delivery and data feedback loop and systems and model monitoring. So this entire concept is called MLOps. Okay, now we will try to see what are the different steps involved in it. Okay, and how does it goes no? Deploying a model into production is a complex affair. I should say that. The reason is deployment of any ML model, okay? Any ML model simply means the integration of the model into an existing production environment, which can take an input and return an output that can be used in making practical business decisions. Okay, so according to Gartner, companies struggle to operationalize machine learning models. So now you see from Gartner's data science team survey of Jan 2018 found that over 60% of models developed with the intention of operationalizing them were never actually operationalized. That means only 40% of the things comes. The biggest issue facing machine learning is how to put the system into an production, right? This is a real topic. So we will try to understand it, and then I'll try to bring in more business perspectives rather than an technical perspective in this session. Okay. Now, having said that, okay, we need to understand machine learning systems differ from a traditional software in 2 fundamental ways. Machine learning is never a full deterministic model. Okay, the reason is the performance of an ML system can't be evaluated against a strict specifications. Instead, it should be always evaluated against the application specific matters. It's like an false positives or negatives, churn rates or sales improvement or any other things, right? So we need to always go with what application we are building, what specific metrics we are seeing, okay? The behavior of a machine learning system is determined more by the data used for training rather than the model used for interface. Okay? Therefore, data collection, data wrangling, pipeline management, model retraining, and model development are the tasks that will never go away. So that's why it's actually different from in software in fundamentally these two ways. So I actually use most of this from some of the blogs. I cite most of the things. Okay. Now, having said this is the fundamental difference between ML and software. This thing I'll try to explain about a business case which we solved sometime back. Okay. So we were trying to solve a design and algorithm to build a recommender system targeted as a multi-agent for online and offline retail. When I say multi-agent, right? So we have a customers or one agents who are the users of that particular thing, and we need to also address the requirements of in sales reps. They also need to address the requirements of in suppliers. We also need to recommend for an operations, day-to-day operations. So that's why we call them as a multivariate things. So what does this does? It basically takes analyzes an historical purchase, click streams and search words, data pattern, and unearth insights that will help in strategize and customer engagement. So this system will build an effective engine whose services will be consumed and client applications in the web portals or mobile apps, etc. So this is the entire purview where we will be discussing our thing. Okay. So what I'll do is I'll now try to explain the different steps. Okay, key stages in any ML production, right? So the first and foremost thing in any ML production environment is basically prediction system building, right? Then we need to have a training system. Then we need to have a serving system. Then training and validation of the data. At production time, we have a production data, and the prediction system should be tested functionally to catch out the code registrations and validations. The training system should have tested catch up upstreams, regressions, and other stuff. And for a production data, we need a monitoring that raises alerts and downtime errors and everything. So this is basically in different stages in ML production environment. Okay. Now we'll try to get into a pipeline of this production, right? So we all know, like, gathering data sources, data analysis and pre-processing, variable selection, and machine learning and model building becomes very important thing. Once we build a model that goes into a business, and that's where uplift evaluation will come. So this is how these three things, which are I marked in red circles, become very important in machine learning pipelines. Okay, as I mentioned in previously. Now, overview of an any ML architecture. What are the ML considerations, right? What any model, ML model considers when it goes to a production. The first one is modularity. Second one is reproducibility. Third one is scalability, and fourth is extensibility, and fifth is testing. Sixth is automation. Why all these things are very important here is it should be easy to modify for future tasks. Okay, if you don't modify this, whatever we are building the pipeline, if you are not modifying it for future tasks, so we are trying to create a mistake. So these are the first and foremost considerations for any kind of an ML thing. Now, how can we do this in a different ways? Like, no, you can train by batch and predict by fly, train by batch and predict by batch, train and predict by streaming, train by batch and predict on mobiles also. So these are the different things where we can think about. Like, for example, if you talk about train by batch and predict by fly, where we'll use in services like REST APIs, and training and persisting done offline when prediction is done in the real time. If it is going to be trained by batch and predict by batch, okay, then the shared databases will be working together to get a real-time prediction. I'll also show
Sir,
you. Yes.
mhm. Sir, sorry to disturb you, but your PPT is not presented. Can you present it on the screen?
is it? Now, is it visible?
No, sir.
I can see my PPT. Can you see my screen now?
Yes, sir.
Okay, right. So uh, I'm talking about. Did you see all these things? From the beginning, it is missing.
So you can continue from there.
Okay, thank you. So I'm just trying to explain about overview of ML architecture, ML considerations, and what are the different methods we can do a predictive model. Okay, so the first one is a modularity. Second is reproducibility, and the third is scalability, and fourth is extensibility, and next one is a testing and automation. The reason why we need to consider all these things is it should be easy to modify for future tasks, and it should be easy to scale for other applications with the minimal response time. So, but at the same time, you have different methods where you can actually train by batch and predict by fly, or train by batch and predict by batch, and train by predict and streaming, and then we can also do it on the mobile thing. So now when we try to see these, like, no, there are different patterns, right? That four patterns with the training, prediction, and prediction result, and latency and prediction and all, like, no, you can see like the different ways. Like, no, for example, if I want to train by batch and predict by thing where we can use REST APIs, on-fly predictions. So this is how we can do. Uh, I'll just try to highlight what is an architectural things we can use here. Like, for example, if you want to train by batch and predict on fly, so this is how you can use it. Like, no, you can actually create your CI/CD pipeline here, and then try to test your model builders and feature extractions and everything on this, and then where we can create a batch processing and all. Now we'll try to get into the next steps of how this entire thing works. Okay. The role of a data scientist comes up with a Jupyter notebook. Okay, then we have to get into the next stage with to production. Okay, so we all know the Jupyter notebooks. Like, now we get an excellent data scientist who develop a beautiful Jupyter notebooks. Okay, now from here, how can we make that into a productionized? That's the biggest question, right? So what we are trying to do here is like there are different methods and different libraries and other notebook type providers link between data scientist and workbench and production. So first and foremost thing is we need to convert this Jupyter notebook into PMML language, what you call them as predictive model and markup language, okay, which is an interchange format of predictive models, okay, to this format. That's the first step we need to do. Once we have that PMML done, then we can go to a conceptual framework for different components in a machine learning system. So the first and foremost thing is for a training and validating data, we need to have trained the system. For that, we need to do different tests. Okay, that testing is basically full training pipelines. Okay, then validation tests, then functional tests. Okay, then for a prediction system, you need to validate it, and you also need to test the functionality of the prediction system. So once we are done with this training and validation, and then trying to do all these prediction things, then we'll go to productionized thing. There we have a server system, and then we'll also need to have monitoring. So in order to put together all these frameworks, like, there are five components which will help in building a production ready machine learning system. The first one is testing and continuous integration. Second one is a containerization. Third one is a web development. Fourth one is hardware and mobile deployment. And fifth is in monitoring systems. Okay, these are the different stage components in the building process of it. Okay, now we are talking about the first one, testing and continuous integration, right? So there are different types of tests here. One is unit test and integration test. Then we need to talk about something called continuous integration, what we call it as CI/CD kind of a framework. Okay, so what are the unit tests? Like we can talk about this test, like training system tests, validation tests, and functionality tests. Then we also need to have an environment where tests are run every time and a new code is pushed into repository before update the model is deployed. So this is the first process to build when we deploy in any model. The second one is containerization. Before that, why we need this? Okay, we have some points to discuss. Machine learning in production is very different from machine learning in concept. Okay, so the beautiful minds of a data scientist will develop an good Python notebooks or good Python codes or good R codes, where we call them as Jupyter notebooks. Okay, there are lots of waste in development cycles. It comes up with inconsistent environment across the team members, wasted time configuration these Python libraries, lost time in configuring the system packages, additional compute resources not easily accessible for all the engineers, and every new engagement in the a project starting from scratch, which requires time to get set up. So this is where the local deployment and environment doesn't match the customer productions. So in order to overcome all these things, okay, then is there anything where we can consider about? There comes the rescue with a Docker. Okay, Docker, it is a computer program that performs an operating system level virtualization, also known as containerization. Okay, so now you can talk about, like, there are different types of this, like you can see apps like like this in a Docker, and then hosting an operation system and infrastructure. You can also have in different things like infrastructure and hypervisions. Okay, and then you can keep all apps in a different guest operating system so that it won't get into in different things. So now we are talking about something like Docker presents how to deal with each of these individual microservices. Okay, that's where we talk about Kubernetes. Okay, which is an open source and a winner, excellent support from leading cloud vendors. Okay, I won't be discussing much on Kubernetes here. Now we'll come to the web development. To deploy any sort of prediction system to a serving system, you want to ensure that model are tested via an process before they enter the production serving environments. Models can be quickly and safely rolled back to in previous serving versions. Especially for web development, you need to be familiar with a concept called REST API, which we discussed some time back. This means serving predictions in response to the canonical formatted HTTP request. Okay, now we will talk about you deploy a code to virtual machines, then scale by adding instances. You can deploy the code as a container and then scale via orchestration. Then you can deploy the codes as a serverless functions, or you can deploy the code via model serving solutions. So these are the different options when we talk about web deployment. Now, the idea is that the app code depends upon different things. Like we were talking about different alternatives of Kubernetes, like AWS Fragile or like DB, Workers, web servers, etc. So now the key takeaways here is if you are making a CPU interface, you can get away with the scaling by launching more servers. Okay, if you are using a GPU licenses, things like TensorFlow servicing, Clipper becomes useful with the features such as adaptive batching. Okay. Now, coming to an hardware and mobile deployment. Okay. Embedded mobile devices have low processors with little things. Now, here, the mobile systems like PyTorch or TensorFlow frameworks are fully featured than full these things. Therefore, we have to be careful with the model architecture and alternative options using this format. Okay. Then it comes to a monitoring, okay, which is a crucial to know that how your ML system is working. Okay, now the model is live. You need to understand how it performs and where it is closing. So a typical monitoring system can raise alarms when things go wrong and what are the things are turning out. Okay, so these are the 5 steps we need to use in any deployment process. So to put it in an all-in-one, there are a lot of different technologies and tech management things, like no, for a data, like you have uh, either it can be an on-prem, like no, you can think about like you have an on-prem, okay, or a cloud environment, okay. There you talk about storage, then you talk about a processing, then you have a databases, you have an like versioning where you have to labeling things. Then it comes to the deployment and training things, like where you have an different distributed trainings frameworks like TensorFlow, Keras, and FastAI, and PyTorch kind of frameworks, and software engineering like Python, Jupyter's, GitHub's. And then you have things like hyperparameter tuning, experiment management, and resource management. Okay, again you can do it both like no on-prem as well as the cloud. Okay, then it comes to the deployment where you're talking about monitoring, and where we are talking about web, okay, and where we are talking about CI/CD testings, okay, and we are talking about different places, right? Here you can host it on where you can deploy it on cloud or mobile or even in a kind of an this thing. So now with this techno framework, okay, we will be coming to like I will be talking something like no, an environment where an enterprise should look around and then should build around, okay, which will help, right? So now you get different sources of data, all these different sources of data. I'm not uh, uh, trying to say like which is the best thing, but mostly I work on Azure, so I'm trying to give my experiences in this. Okay, so you talk about different things. The first and foremost thing is we need to have a data pipeline, okay, data source systems, okay. In the data source systems, with pipeline, we'll go to an integration layer. With the integration layer, it basically goes into a data lake, okay. Then the data lake basically gets into like no, you get in different environments like a sandbox environment, DevOps environment, production box environment, okay? Then it goes to an application layer, right? So the first and foremost thing everyone looks at is an application layer, whether it's an visualization or basically in blob storage or embedded in device or anything, right? Web application kind of thing. Then the second thing is basically what sandbox is behind this and what are the different technologies used to build this sandbox. Like you know, data scientists and data engineers are using it. Then the third component is basically in DevOps, and fourth is basically in production box. Okay. Then it comes to a lake and then integration layer. That's how your entire system should be working for you. So and then I basically use Databricks. I'm very favorite of this because it becomes very easy for you to host your notebooks. Okay. Now I'm talking about a concept called DevOps to MLOps. So when we talk about DevOps, which is basically code reproducibility, code testing, and app development, whereas MLOps, instead of code, it becomes a model, right? Code is only an integral part of a model, right? Model has so many other things, okay? And it's also a model validation and model deployment and model training. So that's the basic difference of it. Now, if you see a DevOps, okay, so they basically prepare it from the data sources, and then they use this Jupyter code or code, whatever it may be, then go to train, then go to registering, then build an images, then deploy the services and all. So this is the DevOps thing. Now, when it comes to MLOps, okay, So MLOps is basically like you have an DevOps and Azure DevOps guys and data scientists using this. You can collaborate, build apps, test apps, release apps, monitor this everything, and then you can retrain this train model. Okay, model reproducibility, model validation, model deployment, and model retraining. So this all things can be achieved through this. Okay. So there are alternatives to Databricks, Google BigQuery, Snowflake, Cloudera, okay, Amazon EMR, okay. These are the top alternatives for this, okay. Now, thank you, and I'm open for any questions. Yes. Okay, that's a very good question. Future for an ML is, as I said, like in one of my slides also I mentioned, okay, there will be a definite feature of an ML. Okay, so for example, if you see the behavior of a machine learning system is determined more by data used. Okay, therefore, data collection, data wrangling, pipeline management, and model retraining and model development are the tasks that will never go away, even if, for that matter, anything you do it. But how an ML guy has to come up is he should be strong skills like mathematics and machine learning and statistics should go hand in hand. You can't have an ML engineer with only an computer science knowledge. Okay. Yeah. So unfortunately, there is an agreement where we can't show it, but like I can talk about the case study which I was talking about. Like, for example, when we want to build an multi-agent recommender engine, right? So the requirement of each and every agent and the devices they use are different, right? For example, customers they do a shopping, either they basically go through their mobile and then they shop it. At the same time, the sales reps will have their own devices where they will be using, and then they will be checking what's their progress and all. At the same time, the ops guys generally depends upon web services. Okay. At the same time, the suppliers like who basically supply and all, they get all these alerts and messages. What is the inventory level and everything. So when we talk about this entire multi-agent model, it's not in one model like where you talk about just do a segmentation of customers and do it. It has to be an plethora of so many models where we need to do and where we need to produce and where we need to make sure. And then when we deploy it has to be like each model for each agent should not get disturbed with other agents and other things. So you need to plan this, all this work, whatever you are trying to do, and then the containerization or dockerization of things, and then that has to be in a very good way, so that the right message is delivered to a right agent. Yeah.
There's a question by Rohan Mathur. What do you think is the best application / framework for deploying models in Python?
Python, you develop models for deployment. I always use Databricks. That's what I said. That's my favorite. The notebooks can be integrated. You mean to say like whether it's a Spider or whether it is in Jupyter notebooks? I always suggest Jupyter notebooks are the easy and then easy deployable, where you can go to client and present also.
Akshat again asked what is the benefit of using Azure over GCP, Google Cloud?
So it's basically a matter of choice. Okay, certain companies are very favorite towards Azure, and certain companies goes for GCP, Google Cloud. It all depends upon enterprise level choice. If Google becomes a competitor for certain companies, they go for ML, like no Microsoft. And then not only these two, there's a two big players again sitting there. One is your AWS, and then you have Alibaba also. It all depends upon choice of a company.
Okay. How do you think ML will impact the auto ML will impact the model deployment? The auto ML.
So yeah, so Auto ML is a very good feature developed for an guys who basically are not so comfortable with coding or something. Okay, but the main problem is like no, the artics. There is always a two different angles of a data sciences. Okay, one is basically an artistic view of a data science versus the scientific view of a data scientist. Okay, the artistic view is like no, you really want to model it in a such a way where your all your ideas and everything has to go. You have to use the science of statistics to model it. So auto ML, in my purview, is lack of that artistic view. It basically you need to take that like no, it's a very simple like no, you go to any ready-made store and then fit the shirt what you want. Okay, or like I always put it in a different way that like no, you take an 42 size shirt and try to fit everyone into that. Okay, so that's the lacuna of an auto ML.
What do you think about the frameworks like Streamlit? Do you think that such easy to use frameworks can be scaled for large ML applications for companies and organizations?
So what framework needs to be used is always depends upon who are your final users. Okay, if your users are comfortable, and then if your users are basically satisfied with it, because the whole concept is like no, you are making your decisions very scalable and reproducible. If that framework is going to address those questions, any framework can be used for that matter. But again, it also depends upon you need to have the resource availability, you need to have an skill set available in an organization.
Devansh asked that do you think artificial intelligence can be implemented with JavaScript?
You can do it, right? But see, first of all, as I said, like no, artificial intelligence is basically a decision-making process. Built-in decision-making support system has to be backed up with MLs. If you are good, you can definitely use Java ML algorithms also. At the same time, any language for that matter is pretty good. Okay, but if you ask my favorite thing, if you ask me for a statistics, I always use R. For all the processing and pre-processing and data frameworks and everything, I'm a big favorite of Python. Okay, in order to create all springs and all the other things, I develop on I give the task to an Java guys to develop it. Okay, so for me, the binding principle for all these things is a statistics and mathematics. If you are fundamentally strong in this, the technological things which we are getting is a kind of an application, and then it keep changing, right? There is no permanency in that. It will keep changing. People are talking about Julia now. Okay, people are talking about Julia, which will might get replaced with like when I started my data science career, I used to use the DOS-based programmings like no rats. Then then Windows came and Windows rats. Okay, then we started getting into SAS. Okay, then it became damn expensive. Then we started using open source libraries like R. Then Python is ruling, right? Now people are talking about Julia, right? So, but what we have not left so far is the basics and fundamentals of statistics and statistical knowledge. Okay, the languages and other things are I'll keep changing, and definitely you need to learn those things. But what is important is your in data science, the fundamentals of statistics and the basics of principles of data.
Ujjwal has a question like, do you think can we reach that point where it is possible that machines reach human intelligence in terms of deep learning models and their deployment?
Yesterday I was discussing with one of my friend in Brazil on the same concept. Okay, so he brought this Elon Musk was little worried about artificial intelligence taking over things. Okay, or Facebook and Google are trying to say that they come up with their own frameworks, and then which is going to reproduce human brains and all. I say that will be that will be always there, but what happens is human beings are human beings, right? You can't replace them, but what you can do is there's only a set of commands where you can indulge, and it will make difference. Like for example, think about some applications, for example, you want to go to somewhere, you just have an Google app open, and then you can reach anywhere, right? In the absence of Google app, what we used to do is we used to go and ask different peoples. Okay, the humanistic side of that is you tend to interact with so many peoples. Now you don't interact with anyone other than your device. Okay, so there is always pros and cons of it. Okay, but I actually support the thought process raised by Elon Musk, because people stopped reading the basic things, basic sciences. People are only using the applications and applications on it. After a certain time, people don't understand what is the theory runs behind it. Then there are some generations who lose the capability of thinking and reproducing new things if you depend upon machines.
Stuti has a question like, will easy to use ML5JS be useful for deploying large scale ML models?
I'm sorry, I really don't know about that. But the technology is evolving, and then you can definitely need to update to the latest ones. But at the same time, you also need to know how many corporations and enterprises are aligned to that technology. Okay, that's a good way to skill up your skills for any new things, because you are all budding. You need to get into market, and then you need to work. Okay, so for any adaptability of new technologies for an old organizations will take some time. Okay, but as an youngsters, we expect you to be in an organization to help the process and accelerate fast. Sorry, Shruti, I don't know about that. I'll learn from you.
Okay. Soumya has a question. How do we make sure no one can tamper with a model which has been posted online?
Okay, that is where you have to use your repositories, where and then you have to give your permissions. The governance things will work if you post it on online or Git repository, right? So you have to be keep that proper security options. If you put it online without any security options, people will tamper it.
All right. We have seen, like, in the last few years, a lot of automated deployment technologies, like mentioned in the above questions. Also, Streamlit and other technologies have become very popular because we don't
Yeah.
need to hard code anything. You just use that framework and it is automatically deployed. So, like,
Yeah.
what is your view on this?
So, see, what is happening is, in a way, it's very useful for the guys who are in the system and whose ability of coding will degrade after some time. Like, no, for example, I reached 40, 42 now. If you ask me to code, I may not be doing the same coder like when I was 24 or 26, right? So for them, this applications will be very useful. But my suggestion to youngsters is you learn these applications at the same time you try to understand what this is trying to do, underlining of this, right? So that is very important. That's my suggestion for most of the youngsters who want to venture into this field.
Rakesh is asking, data engineers versus data scientists. Which role do you
Yeah.
think is more demanding?
If you ask me, both are very important. But what is my favorite subject is data scientist because it has an artistic view, right? So I put it in a different way, like, no, okay, दिमाग से करो, दिल से सोचो, okay, all right. Your heart comes and your brain comes, okay. That's where the data scientist will come. But data engineers, without the help of them, data scientists may not move. I started this with calling them as a team sport. Okay, it's like 4 into 1,000, like, no, relay kind of a thing. It's not an sprint, like, no, one person running, and it's not a swim lane. Both has to go hand in hand.
Gayatri has a question. What is the best strategy for online interference?
I'm not sure. Online interference of?
In general, I think she has a question. What is the best strategy for online interference?
Sorry, I not.
All right.
Yeah.
So I think we are done with the questions, sir.
Yeah.
Okay. If you have anything else to convey to them, that would be good.
Nothing. And then I take this opportunity to thank Aditi and the team. I always love to interact with students. Okay. And I wish you happy learning. And then I wish you a good career ahead for you guys. And then I like to put all my wishes for you. Okay. And good initiative. Keep it up, guys.
All right. Okay. Thank you so much, sir, for conducting the session.
Yeah.
And thank you all the viewers for joining us.